I am Jiaao Chen, a PhD student from Georgia Tech. Here I'm going to talk about our recent paper, LADA, Local Additivity-Based Data Augmentation for Semi-supervised NER. This work was done with Zhenghui Wang and Diyi from Georgia Tech, Tian from Google, and Zichao from Citadel Securities. Named entity recognition is one of the most fundamental prerequisites for many NLP applications. The task is, for a given unstructured sentence, we need to figure out the specific semantic category of entities. So for example here, Michael Jordan is a person name and Berkeley is a location. Most current NER models heavily rely on abundant label data to get the state-of-the-art performances. Such reliance heavily prevents them being applied to new settings, like social media context, or medical context, or low-resource languages. One possible solution is to use data augmentation to augment the limited label dataset and get better performances. There are lots of prior work on textual data augmentation. One category is using adversarial texts at the token levels. However, they suffer from creating diverse examples. Another category is to do the paraphrasings at the sentence levels. However, they fail to maintain token-level labels, which make it impossible to be applied to sequence-level learning, like the NER. There are one recent categories of data augmentation where they use the interpolations in the hidden space to create virtual samples. And in this work, we focused on such interpolation-based methods. Previous work using the mix-up techniques in text domain usually randomly sample examples to mix up together. However, in this way, it may inject too much noise for token-level learning. To overcome such limitations, we propose LADA, Local Additivity-Based Data Augmentation, where we constrain the samples to mix up to be close to each other. And we propose two variations, intra-LADA and inter-LADA. The intra-LADA refers to interpolating each token's hidden representation with other tokens from the same sentence, and this was achieved by random permutations in the original sentences. Intra-LADA could increase the robustness towards word orderings. Inter-LADA refers to interpolating each token's hidden representation with each token from other sentences, and those sentences are sampled from a combination set of k-nearest neighbors and randomly sampled sentences. By sample sentences from their k-nearest neighbors, we could see the similar context with different entities, or same entity within different context, or the same entities but in different word forms. Those informative labels could enhance the NER model. Furthermore, to alleviate the dependence on labeled data, we propose a semi-supervised LADA, where we incorporate unlabeled data through consistency training. So for unlabeled sentence, we first generate their paraphrases, and then we perform the consistency training. Specifically, we constrain that the unlabeled sentences and their paraphrases should have the same number of entities for any given entity type. Through experiments, our intra-LADA and inter-LADA are better than all the baseline models, and semi-supervised LADA further improve the performance, especially when there are less labeled data. To conclude that, in this work, we propose LADA that can perform interpolations in the hidden space among closed examples to generate augmented data. And we found that sampling strategies of mix-up for sequence learning are really important. And we propose semi-LADA that designed for the NER could further improve the performances with limited training data. We publish our code on the GitHub. If you are interested in our work, please check out our paper and come to our EMNLP presentation sessions. Thank you.